So we're going to talk about solving quadratic equations. And first, I'm going to talk about what a quadratic equation is. And to do that, I need to talk about quadratic expressions. So we know that we have a quadratic expression when we have the sum of three different types of terms. We might have constant terms, x terms, or if whatever our variable is, terms, and x squared terms. So for instance, we could have something like 3x squared plus 10 minus 9x. So we have an x term, a constant term, and an x squared term. We could also have something like 1 plus x squared. Notice that in this one we don't have an x term and we don't need an x term. So long as we have this x squared term, and that's the highest, the 2 is the highest exponent that we see, we're going to have a quadratic expression. And then another example would be like this 2x squared plus 3x plus 1. So a quadratic equation comes about when we have two quadratic expressions being set equal to each other. And we could actually have like a linear expression over here. And our goal is to figure out what x values work. So for what x does 3x squared plus 10 minus 9x equal 1 plus x squared? So the first thing that we're going to do is we're going to kind of clean this up, and we're going to get it in standard form. And when I say standard form, I mean that ax squared plus bx plus c is equal to 0. And so the way that we can do that is eliminating everything on our right-hand side. So I can subtract x squared from both sides. And I can also subtract this 1 from both sides. And then I'll end up getting 2x squared plus 9 minus 9x is equal to 0. We can identify that our a is going to be equal to 2 right here. Our b is going to be equal to negative 9 right here, the coefficient of our x. And our c is going to be equal to positive 9. If it helps, you can actually go ahead and rearrange this 2x squared plus 9 minus 9x in decreasing degree. So we would have 2x squared, and then we'd write our minus 9x, and then we'd write our plus 9. And so now, hopefully now, definitely you see that our a is going to be 2, our b is going to be negative 9, and our c is going to be positive 9. So once we've identified those, we can go ahead and plug into our quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to go ahead and plug those values in. So we've got negative 9 gives me a positive 9, plus or minus. Negative 9 squared gives me an 81, minus 4. I've got my a is 2, and my c is 9. And then I'm dividing by 2 times my a is 2. Okay, so now that we have all of those values plugged in, we just go through and do order of operations and simplify as much as we can. So I've got 9 plus or minus under the square root. I have an 81 minus 4 times 9 gives me 36. And then I multiply that by 2, I get 72. And then I divide by 4. When we simplify this, we've got 9 plus or minus under the square root. 81 minus 72 gives me a 9. And then I have divided by 4, which is equal to 9 plus or minus square root of 9 gives us 3. And then we have divided by 4. And now we can finally kind of separate these two situations out. In one situation, I have 9 plus 3 over 4, which gives me 12 over 4, or 3. And in the other situation, I have 9 minus 3 over 4, which gives me 6 over 4, or 3 halves. And so these would be the two solutions to my original quadratic equation. All right, we have another example. This one's already written in standard form, so it's a little quicker. We can just read off what our A, B, and C are and plug into the quadratic formula. So we've got x is equal to negative, our b is a 1, plus or minus square root. Our b is 1, so b squared is going to be 1, minus 4. Our a is 2, our c is 3, and I'm dividing out by a 2 times a, which is 2. So then I write this is equal to negative 1 plus or minus square root. I've got 1 minus 4 times 2 times 3, which is a 24. All over 2 times 2 gives me 4. I keep going. I get negative 1 plus or minus. Now things get a little strange. I have the square root of negative 23 divided by 4. And if we're just working with real numbers, we'd say that we can't take the square root of a negative number, right? Because we would need a number being multiplied by to itself, giving us a negative number, which doesn't really make any sense in the context of plain old real numbers. So then complex numbers come into play. Now, we're going to define I as the square root of negative 1. And this is going to let us simplify this number over here. So I'm going to say this is equal to negative 1 plus or minus. I'm going to write the square root of negative 23 as the square root of 23 times the square root of negative 1. And now this negative 1, I'm just going to substitute out for I. So I've got negative 1 plus or minus square root 23i being divided by 4. And now these are going to be my solutions. I've simplified as much as I can. All right, got another example. Again, it's already in standard form, so we can just start plugging into the quadratic formula. We've got x is equal to, our b is negative 12, so negative 12 gives us a 12, plus or minus square root. We've got 12 squared, which gives us 144, minus 4. Our a is 3, our c is 12, divided by 2 times our a is 3. When we go to solve this, we notice another funky thing. When I go to take the square root, I've got 144 minus 4 times 3 times 12 gives me 144 again. And so, in this next step, we end up getting the square root of 0, right? And so, this whole piece goes to 0. The square root of 0 is 0. And so, we just end up with one solution, which is 12 divided by 2 times 3, which is 6. And so, we get one solution of 2.